Hello, everyone. My name is Abdeslam Boularias. I'm professor of computer science at Robotics University. This is joint work with my PhD student, Junchi Liang, and we'll be talking about learning category level manipulation from point clouds with dynamic graph CNNs. This is an example of the experiments that we did where we demonstrate to a robot how to perform tasks such as pouring, and we use ordinary objects for that. And then we went to test the robot on objects that are completely different from the ones that we used for demonstration, such as, for example, larger cup, larger bottle within the same category. And the robot learns to generalize the skills that it observed into these new shapes and new dimensions. And that's the whole point of this paper. This is a system overview where on top you can see an example of demonstration, which is sequence of RGBD images where we demonstrate certain task. And then we use the hierarchical neural network to learn this three-level policy, high level, intermediate level, and low level policy. And then we use that to test the robot on entirely different objects within the same category, where in this case, for example, we provide much larger brush and much larger box, and the robot can perform similar kind of simulated painting on these new objects. So the proposed architecture has these three levels: high level, intermediate level, low level policy, which I will explain in the following. So the high level policy takes as input an RGBD image of the scene and then performs segmentation using off-the-shelf segmentation tools. And for each detected point cloud, we can extract two kinds of features: the appearance features and also shape features using dynamic graph convolutional neural nets. And we do this for every object in the scene. Then we will concatenate all these features, and then we will consider for every pair of objects, like object O1 and object O2 here, like the bottle and the cup, we will create a joint feature vector that will tell us roughly how appropriate is it to use this kind of object with as a tool with respect to this other object as a target when we want to perform certain tasks. For example, here we're talking about pouring task. And we take this joint vector and we put it as an input to a neural network that gives us a score that tells us how good or how does this object matches with the demonstration as a tool, and how does the other object matches with our demonstration as a target. So we train this network from the demonstrations, and then basically we predict for every pair of objects in our test scene the score, and then we just select the object that has the highest score. The intermediate level policy will receive the selected two target objects from the high level policy and then predicts a pose or 6D pose in which we need to place the tool object relative to the target object. And the low level policy is basically just sequence of moves that of the end effector that will adjust to the features of the tool and target object, for example, the height of the cup in this example. These are examples of the experiments that we did. Here we are demonstrating how to perform stacking task where we put small object and we try to stack it on top of the largest object in scene, and the robot generalized to entirely different shapes or different sizes, basically, in this case. And we also have other objects that are completely irrelevant to the task, and the robot learns how to ignore those objects and just select the cuboid objects in this case. Now we are doing the same thing here, but we are teaching the robot to perform the opposite thing, which is stacking the largest object on top of the smallest cuboid object in the scene. And we test it on different sizes also at the same time. We also did some comparisons. More results are in the paper. Here we are showing how the robot can generalize to different shapes or different sizes for performing the pouring task. And as you can see, the objects here are quite different from the ones we're using during demonstration. Here, for example, we provided a much larger bottle and much larger cup than the ones we use in demonstration. It learns also how to select the object and also how to place objects relative to each other. And now we are doing simulated painting, where we pick brush and put it on top of another object. And it learns also to perform this scale with different sizes and actually substantially different sizes in this case than the ones we used in the demonstrations. So more results are included in the paper. And yeah, thank you very much.